Okay, everyone, so these are going to be your first set of notes for a small little continuation of our motion unit before we move on to a forces unit later on this semester. So get out your notebooks, add these notes so that you can do a good job on your upcoming quiz. So what we've been studying up until now, with uniform motion, or in other words, constant speed, the object has been traveling the same speed throughout the time interval that we've been measuring. So we end up getting data like what you see here in this tape, where the marks are approximately the same distance apart. And we've also learned, hopefully by now, that speed is equal to distance divided by time. And we just took a test over this, so we are mostly done with uniform motion, but there are still a couple of things that we're going to be talking about with this second part of the unit that are still going to concern uniform motion. So I'm going to mention those on my next blackboard here. So with our uniform motion unit that we've gone over so far, we were seeing graphs that mostly looked like this right here, where you had a perfectly straight line starting at 0. And that's fine, that is constant speed, but we're kind of done with this. We know that this is constant speed because it is a straight line. And we also know that this object is moving away from 0 because we always know that this is right here is 0. So that object is moving away from 0. Another way to say that, so if we write that down, go ahead and write that down. Moving away from 0. Another way to say that is that the object is moving in the positive direction. Because if I look along the position part of my graph, the numbers are going to increase. And as this line goes, the position is going away from 0, so my numbers increase, so I'm getting more positive numbers as the object goes. So that is something that we've already seen a bunch of times, so we're not going to look at it as much this time. Something we are going to look at this time is a graph that looks more like this. And if we look at it, knowing what we already know, is this constant speed or not? What do you look for when you're trying to identify constant speed? You look for a straight line. Is this line straight? Yes, it is. So again, we can say that this graph over here is constant speed. So we're good to go. We already know something about it because it has a straight line also. That's how I know. The thing that we don't know is the direction. Like over here on the left-hand side, we said that this yellow line was moving away from 0. But what is this object doing? When time started here, my object was way up here, not even close to the 0 point. So what that means is that this object is actually moving toward 0, or basically moving in the opposite direction of the other object. So if it's the opposite direction, as you can see, as the object travels, its position is decreasing or moving in the negative direction. So we can go ahead and add that. And that is something that we are going to be studying in this section. We want to be able to identify things that move in the negative direction versus things that move in the positive direction. Another type of graph that we're going to be looking at and trying to figure out what's going on is a graph that looks like this on the left. So what I like to do is break it up into its two sections. We have section 1 right here that is moving up, and then we have section 2 that's flat. So let's describe this as far as the sections. First of all, you want to ask yourself, is section 1 constant speed? Yes. Yes, it is, because it's a straight line. So we can say that about section 1. At that time, the object is going at a constant speed. and in the positive direction because it's moving away from the 0 point. Section 2, though, yes, the line is straight, but it's not going away from 0, it's not going towards 0, it is staying at this position right here. And if something stays at a position, that means it's not moving at all. So that flat line, or section 2, means that there is no motion whatsoever. And if you have no motion, the object is stopped, which means it's not moving in any direction. So no motion is all we have to put. Now, just to have another example to go off of, I've added a second graph here, and I'm going to go ahead and break it up into its two sections too, so we can describe them. So in section 1 of this graph, do we have constant speed? Yes, we do. It's a straight line. So I can use that to describe it. It's easy enough. It is constant speed. It's moving toward 0, which means it's getting closer to the negative numbers. So this is the negative direction. So it's moving toward 0 instead of away. And then we have another section 2 that's flat. And we said that anytime something is flat like that, the position is not changing. And if your position isn't changing, you're not going anywhere. So section 2, no motion. So in reality, both of these graphs have something in common. The object moves for about half the time at a constant speed, and then the second half of the time the object stops and does not move at all. So that pretty much concludes uniform motion for us. That's kind of all that we're going to study as far as uniform motion. So we're going to start moving on to a different type of motion now. So go ahead and start a new section in your notes that is accelerated motion, because this is kind of, it's all going to be wrapped up on the same quiz, but this is a different kind of motion, so you want to make sure that it's separated from your previous notes you've already taken. So this is where we start talking about acceleration. And there are a lot of misconceptions about acceleration, and we're going to talk about a few of those. So the definition for acceleration is simply change in velocity over time. And velocity isn't a word that we've used yet, actually. Velocity is actually different than speed, contrary than what you might believe. It has to do with speed, but slightly different. Velocity is actually speed with direction. So that means velocity can be positive or negative, kind of like position can be positive or negative. It includes direction. That's important because acceleration has to do with direction also. So we've got to discuss when acceleration actually happens. And of course, everybody knows the first time that acceleration happens. When you hear the word accelerate, you automatically think when you're speeding up, you are accelerating, which is true. You are accelerating when you speed up. But how many of you have heard the term deceleration? I bet a lot of you are thinking yes. I've heard that said, or I have said that, deceleration. I hate that word because it's not a thing. In physics, there's no such thing as deceleration because acceleration is also when you slow down. So actually, if you're slowing down, you're actually accelerating, not decelerating. So I don't want to see deceleration written on any of your papers ever. It's not a thing. The other time that you can accelerate is actually if you change direction. So you can actually be going at a constant speed, but take a turn, like so, and you are actually accelerating at that point, even though you're not speeding up or slowing down. But you can do any combination of these and be accelerating. So now that we know what acceleration is, we need to know what a graph looks like when an object is speeding up, or what a graph looks like when an object is slowing down. So that's going to be what we're going to investigate here at the beginning of this unit. So what I want you to do, now that you are finished with these notes, in order to figure out what these graphs looks like, we're going to be doing a lab. So I want you to go back to Google Classroom, and then come up and see me, and I will hand you the lab, and then you will fill out the parts of the lab that I have pictures of on Google Classroom. So you don't have to go through a video to fill out the pieces of this lab. I have pictures written down of what you need to write down in your lab to be ready to go tomorrow. So all you have to do is pull up those pictures, copy down what I have written. We will have a quick discussion about it tomorrow before you start your lab, and we may talk about it even at the end of class today. So just make sure that you get that done as quickly as you can, but be careful, read, so that you know what you're doing.